Okay. Recording is started. Let us start with the topic. So now let us go with the next topic called as diesel generator size calculation. Now when you're going to the DG set calculations, what are the changes you'll have? Okay. I've just taken the same load here. All the load. But you'll have one more few things that will be added is nothing but your DG set self load will be added. I've taken the same load, lighting load, power load, HVAC load, plumbing load, as well as the lift load. But a small change that I added in that is DG set self load. Now what is this DG set self load? The DG set self load means, see, when you're going with DG set self load, what do you mean by DG set self load? इसका मतलब क्या है? When the generator is at, just a minute, huh? Yeah. So when it comes to DG set self load, what do you mean by this DG set self load? The DG set self load means, see, whenever you're going with the generator, in the olden days, the generator was switching on through manually. Like we need to rotate that, and then when you are rotating at a speed, certain speed, then that automatically creates that what are the magnetic field is it cuts, and it automatically used to rotate. Okay. But nowadays we are getting only a generator with a key operator. Means we have a small key where you are operating, or when you're pressing a button which have a battery and it connected to self starter. We have a charging alternator or self starter. That charging alternator will start creating the motion, and then automatically the generator switch on. Means that charging alternator has to be charge your battery whenever the generator is on. Why? Because it is charging only when the power is on, when the generator is on. So when the, like example, your vehicle is also there. Okay, in the vehicle we are getting self starter. So in the olden days we used to kick it up, or we used to put in a gear and we used to push it in the back. So the same way, but in the present scenario we are getting a self starter, so that we have a ignition kind of thing. So when you're pressing, automatically the self starter switch on, and now vehicle will start. So here in terms of generator, we have that load. I taken that DG set self load is a 5 kilowatt. This is the maximum. You'll have some 1 kilowatt or 2 kilowatt, but we are taken, when you're calculating it up, we are taken the maximum, because charging alternator jo rahega, that is a maximum load I taken as in 5 kilowatt. DG set self load I taken, because inside the generator we have a radiator. Beside the radiator we have an exhaust fan, or even you'll have a, inside the canopy, generator canopy, you'll have a lamps. Okay. Considering all this parameter, I taken the maximum DG set self load as in 5 kilowatt. So when you add up all these fillings, again the same step 1. What is step 1? Calculate the total connected load. Okay, we added the total load. Step 2. What is step 2? Add 10% extra for the future expansion purpose. So we had taken 10% extra for the future expansion purpose. We got 1314.5 kilowatt. Step 3. What is step 3? Calculate the maximum kVA based upon the demand factor of the building. Calculate the maximum demand based upon the demand factor of the building. Same I took as in a commercial building where 0.8. I got the total load as a 1051.6 is the maximum demand. Now based upon this demand, I need to calculate the kVA. So what is the next formula? kVA is equal to kW by power factor. So when I take kVA is equal to kW by power factor, I got 1314.5 kVA. Then come into the based upon the efficiency. So what is the generator efficiency? I told you 80%. Transformer efficiency was 90%. Generator efficiency was 80%. UPS efficiency 78%. Considering this parameter, when I calculated the generator size, considering the diesel generator, considering the derating factor of generator, kVA is equal to kVA divided by derating factor. That is 1314.5 divided by 0.8. That is 1643.125 kVA. Next, when you see the nearest size availability, these are the generator sizes which are available in the market. So I have taken the nearest size of the generator is nothing but 1800 kVA. Now again we need to do the checking of the generator same way. So I need to do the checking of the generator by considering the highest utilized motor. So based upon the power factor 0.8, I got 175 kVA. Then again based upon the derating factor 0.8 to 18.75 kVA. Mean to say that to run that motor we require 18.75 kVA. Now considering the 4 times extra, to 18.75 into 4, 875 kVA. This is what, which is nothing but the starting. So now I'd remove that with a 1643.125 minus 218.75. I got 1424.37 plus 875. I got 2299.75 with motor load. And the same way when you're saying considering overload withstanding capacity as 50%, we have checked our proposal is 1800 into 1.5, that is 2700 kVA. So 2700 is greater than 2299.75. Then the proposed generator, that is 800 kVA, is satisfied. Same way, but only few parameter changes. You'll add up one more load as an extra. Second thing, when you're taking this one, what is that? When you're taking the derating factor, here we are going to consider the derating factor of generator where it is 80%. So you'll be taking the generator derating factor and you'll be calculating according to that. So proposed generator sizes, we got 800 kVA. Okay. Now the next is even after multiplying with 1.5, if my generator fails, what I told you, the same like transformer, if it is proposed fails, we need to go with the next availability size of the generator, and we need to check, okay, whether it's satisfied or not. That will be the final proposed size of the generator. Okay, now next is UPS sizing. Now what is the purpose of UPS? As I told you, the purpose of UPS is nothing but uninterrupted power supply. The purpose of UPS is nothing but uninterrupted power supply, where to give a backup for a given loads. And when you're going with the UPS, I already told you, we are not going to give the UPS for the critical loads. What are critical loads, guys? Can we give the UPS to the motors?
No, sir.
No, and not
No,
even
no.
AC also. We are not going to give it to the AC. Only the lighting loads, that is lights, fans, and
Fans.
normal sockets. Okay,
Yes.
we don't give it to power sockets even, we give it to lights, fans, and normal socket. So now let us take a small example, and for that we'll do the UPS calculation also, and battery bank calculation also we'll study. Okay, now we know the theory of UPS. What is the purpose of UPS? Whenever the main power is there, the battery will get charged, as well as the power will go to the load. Whenever the power cut is happening, whenever the main power cut is happening, the battery which has been charged will start discharging the power to the load. Okay, so now coming to the UPS, first let us calculate the UPS size required for the building. Okay, now UPS load details, step-by-step sequence of calculation, and battery bank step-by-step calculation also will see. Now when you see, I taken a small example of 3 floors building, and I have taken here as a lights and computer, that is normal socket. But if you want fans, we'll take the fans also. But when in reality, what happens, for every flat we need to put a UPS, right? For every flat we need to put a UPS, or for every floor we need to put a UPS. Then in that, when you are taking, you need to take whatever the load which is required by the client, according to that load, to meet that load, what is the size of the UPS we require, that we are going to do the calculation. So here I taken a small example, assuming that 3 floors building. First floor, there are 15 lights are there, which is of how much wattage? 36 watts. And there are 10 computers, which is of 100 watt. Because normal socket, the wattage is 100. So that is normal socket. So I taken 10. Floor 2, there are 20 lights, which is of 36 watts. And there are computers of 100 watts, 30. Floor 3, 15 lights of 36 watt and 10 computers of 100 watts. Now I taken a small example. If you want fans, you'll add a fans also. Now let us calculate the UPS size required for this load, as well as what is the battery bank size required to get a backup for a particular time. Client बोलेगा मुझे 2 घंटा या 1 घंटे का backup चाहिए. If I want to get 1 hour or 2 hours of backup, what is the age of the battery we require? That everything we will study now. Okay, so now let us see same 5 steps calculation. No? Load KVA, it's a transformer, generator, UPS, they're all written KVA. So we need to calculate the power source. Okay, so what are the first steps? Calculating the total load. Okay, calculating the total load. So total load is nothing but first lighting load plus power load. Now when it comes to lighting load, floor 1, how many lights are there? 15 lights are there of 36 watt, 15 into 36, 540 watt. Floor 2, there are 20 lights, 20 into 36, 720. Floor 3, there are 15 lights, 15 into 36, there are 540. So the total lighting load is how much? 1800 watts is the total lighting load. Next, coming to the sockets or computer load. Floor 1, 10. Floor 1, what are the points we have? Floor 1, we have 10 sockets, 10 systems. So 10 into 100, that is equal to 1000 watts. 30 into 100, that is 3000 watts, and 10 into 100, that is equal to 1000 watts. So the total system load is equal to now how much? 5000 watts. 5000 watt is the total load. Now when you add up the total connected load is equal to lighting load plus computer load. That is equal to 1800 plus 5000, that is 6800 is the total load. Now for this 6800 watts, we need to take 10% extra again for future expansion. So we have taken 10% extra for the future expansion, that is 6800 plus 10% of that is 7.48 kilowatt. Then we need to calculate the KVA required. अभी मुझे कितना KVA चाहिए इतना लोड को देने के लिए, तो what is the KVA required based upon the power factor, that is KVA is equal to KW by power factor. We need to calculate the maximum demand. So when it comes to maximum demand, guys, irrespective of your building, whether it's a residential or commercial or industrial, always for the UPS, the demand factor should be always unity. Okay, for transformer generator, it's not like that. But when it comes to UPS, irrespective of the kind of building, always the demand factor will be always 100%. Why? Because whenever there is a power cut happening in a room, we are not giving all the lights, all the fans in the UPS. We are giving only limited loads. Like if suppose in a room we have 4 lights, 4 fans, means we are not giving 4 lights and 4 fans on the UPS. At least we'll give 2 lights and 2 fans and 1 socket on the UPS, so that it's an emergency. Whenever the power cut is happening, that should be worked on. So when you're giving the emergency and limited load, so obviously whenever there is a power cut, all the loads will switch on at any cost, they'll be used. Okay, so that is the reason whenever you're doing the UPS calculation, irrespective of the type of building, always we need to take the demand factor as a 100%. That is the reason I taken 1 year, that is 7.48 kilowatt. Am I clear?
Yes,
Yes,
sir.
sir.
Okay, so next is calculate the KVA required based on the power factor. So KVA required based on the power factor is equal to KVA is equal to KW divided by power factor, that is 7.48 divided by 0.8, that is 8.5 KVA. Now we got 8.5 kVA, but even UPS will have a losses in considering all batteries and all. Considering the calculate the maximum kVA required based upon the derating factor of the UPS, that is 78%. So considering derating factor is in 0.8, so kVA is equal to kVA divided by 0.8, that is 8.5 divided by 0.78, that is equal to 10.89 kVA. So the nearest to UPS size, nearest to UPS size is how much? 10.89 means it's around 12 kVA. So I just checked with the market availability. I taken the UPS sizes in 12 kVA. Okay. Now when you're taking 12 kVA, now what is that we need to do? Do we need to checking here, guys? Do we need to do checking here?
Sir, we need to check that.
We no need to do the checking now here. Why?
Why,
Because
sir?
in the loads we don't have inductive loads now.
Yeah. Okay.
Okay. When
We
we
are
have
not
done the
connecting motor.
transformer calculation, when we have done the generator calculation, we have done the checking. Why we have done the checking? Because in your loads, there are inductive loads where the drawback of the loads are they take high power at the time of starting. So when you are doing the generator calculation, transformer calculation, we were just checking whether my proposed transformer or generator will able to withstand that much of load or not. So when it comes to your UPS, we don't have inductive loads. Now. We have only the lights and fans on normal socket. So when you are going to do the UPS calculation, we don't do any checking of the UPS. That is the final, which is 12 kVA. But what we require for the UPS, we need to calculate the battery bank calculation for the UPS, because UPS, what is the working principle of UPS? Whenever the power is there, it will start charging your battery as well as the power go to the load. Whenever the power cut is happening, as there is no input supply, whatever the battery which has been charged will start discharging the power to the load. Yes or no?
Yes, sir.
Others?
Yes, sir.
Sir.
Okay. So now we need to calculate the battery bank calculation for this. We need to calculate the battery bank calculation for this UPS. Now, in order to do the battery bank calculations, we need to do the battery bank calculation. First of all, before going to do the battery bank calculation, first of all, we should know what is the client requirement. Now, what is client requirement? How much time he want the backup? First thing. Second thing, whether he want to go with a battery of SMB or SMFB. What do you mean by SMB or SMFB? Like example, in the batteries, we have a lead acid batteries or lithium batteries. In the batteries, we have lead acid batteries or lithium batteries. So, in the same way, in the UPS terminology, we call them SMB and SMFB. What are they? Let us see. So now let us do the battery bank sizing calculation, for which we need to know first of all what is the type of battery, what should be the load, and what is the backup time required. So before going to do the battery bank calculation, first of all we should know certain standards about the UPS. Okay, guys, you know stabilizer.
Yes, sir.
Yes, sir.
Okay, so what
Stabilize the voltage.
Yeah, it will stabilize the voltage and make sure that it will give a constant output voltage. Okay, because if the input voltage you are getting is less, the equipment should not get damaged. So inside that you have a small booster transformer which step up the voltage and will make sure that you will get constant 230 or 415 voltage. Okay, in the same way, if the high voltage is coming, it will reduce the voltage and will make sure that you will getting a standard constant operating voltage is 230 or 415. So as what is the purpose of stabilizer? To protect your electrical equipments, we are going to put a stabilizer. In the same way, in the UPS also we have that feature. What is that feature called? High voltage cutoff voltage and high voltage and low voltage cutoff voltage and nominal voltage. Now, what do you mean by this high voltage cutoff voltage and nominal voltage or low voltage cutoff voltages? High voltage cutoff voltage means it's 110%. What is 110%? Ki suppose if I'm not 12 kV is nothing but a single phase, na? Okay, so high voltage cutoff means 110%. 110% का मतलब क्या है? if the input voltage is getting 253 से ज्यादा है, if the input supply you are getting it to, if you are giving the input supply to the UPS, and if that input supply is getting more than 253, UPS will not reduce the voltage, it will bypass the voltage, because UPS is not like a transformer which will step up and step down, okay, booster and all. UPS क्या करेगा, when the input supply you are getting, when the input supply you are giving to the UPS, and if that input supply is more than 253 voltage, what the UPS will do, it will cut off the main supply and it will start discharging the battery power to the load. Okay, the same way low voltage cutoff, when the input supply you are getting 207 say below, then it will cut off the main supply and it will start discharging the battery power which has been charged, it will start discharging the power to the load. The next is nominal voltage. What is nominal voltage? Nominal voltage is something like 100%, that is constant voltage, that is 230 voltage. Means you are getting 230, then output is also 230. So this is called nominal voltage, high voltage cutoff and low voltage cutoff. Nominal voltage is 100%, high voltage cutoff is 110%, and low voltage cutoff is nothing but equal to, high voltage cutoff is 110%, that is 253, and low voltage cutoff is 207, that is 90%. Okay, these are the standards which are there according to the manufacturer and the UPS, that just like stabilizer, but stabilizer will not cut the power, it will either stepping down the voltage and step up the voltage with you. But when it comes to UPS, no, it will not cut off the it will cut off the power, and the battery which has been charged will start discharging the power to the load. So what I'm telling, if the input supply to the UPS is getting up to 230, 253 is okay. So if the voltage is coming more than 253, it will cut off the main supply. The battery which has been charged, that will start discharging the power to the load. Okay, the same way if the input supply is coming below 207, the equipment should not get damaged. So to protect the equipment, what the UPS will do, it will cut off the main supply and the battery which has been charged will start discharging the power to the load. This is called low voltage cutoff, high voltage cutoff, and the nominal system voltage, that is 253 or 230. Okay, am I clear this one?
सर अगर लोवेस्ट सिस्टम वोल्टेज जो है, अगर वो 200 तक चले जाता है मिनिमम और कम होता है तो वो, और पावर रहता है फिर भी, तो उस कंडीशन में भी बैटरी भी चले जाएगा.
हाँ, बिकॉज अपन को यूपीएस के अंदर अपन को स्टैंडर्ड रहेगा ना कि अपन स्टैंडर्ड लो वोल्टेज कट ऑफ, हाई वोल्टेज कट ऑफ, जब क्या करेगा, सी पावर बोले तो मेन पावर को कट कर देगा यूपीएस, मेन पावर को कट करके जो भी बैटरी चार्ज हुआ है वो बैटरी डिस्चार्ज करना स्टार्ट होगा. बिकॉज अपन को यूपीएस का वर्किंग प्रिंसिपल क्या है, वी हैव टू टाइप्स ऑफ यूपीएस, ऑनलाइन यूपीएस, ऑफलाइन यूपीएस. ऑनलाइन यूपीएस, ऑफलाइन यूपीएस में क्या है, जब मेन पावर है तो बैटरी चार्ज होगा और मेन पावर लोड को भी जाएगा. ओके, तो जब मेन पावर है, अगर वही मेन पावर अगर लोड को जा रहा है तो लोड डैमेज होगा ना, राइट. तो उसी के लिए अपन क्या कर रहे हैं, वो लोड को भी सेफ्टी करना है और आपके इक्विपमेंट को सेफ्टी करना है. तो उसी के लिए अपन क्या कर रहे हैं, इन द यूपीएस वी हैव दैट कट ऑफ वोल्टेज. तो जब अगर आप मेन सप्लाई है बट अगर वो सप्लाई कम है तो जब क्या करेगा, आपका इक्विपमेंट डैमेज नहीं होना है, तो उसी के लिए अपन को लो वोल्टेज कट ऑफ बोल के रहेगा, which will cut off the main supply. Battery will start discharging the power to the load. We'll have a small voltage relay. Okay, relay. That relay will sense the low voltage and automatically it will make the switch from NO to NC and it will start discharging the battery power to the load and the main power will be off.
ऑनलाइन यूपीएस में ऑटोमेटिकली चार्ज भी होता है क्या?
ऑनलाइन यूपीएस में क्या होता है, see, okay, I'll tell you a small difference first, roughly. Have you gone through the videos? I had shared the videos. Okay, and now see here. The first is you have here, this is the main supply. यहाँ पर आपको main supply रहेगा. Then what is the first instrument we need to put here? AC to DC, na? This is the AC supply, right? Okay, so this is AC supply. What is the first instrument we need to do? We need to put rectifier. Rectifier which converts AC to DC. Okay, you are giving the input supply as an AC. First is rectifier which converts AC to DC. Then again, this power will go to the battery charger. Battery charger. This power will go to the BC battery charger, and battery charger will start discharging the power to. Battery charger will start discharging the power to the battery. Then the batteries will get charged. Batteries will get charged. Okay, batteries will get charged, as well as the same power will be going to the inverter circuit. Same power will be going to the inverter circuit. Now then what does that inverter do? Now first is AC supply. AC will be converted from with the help of rectifier. AC is converted to DC. Why? Because the battery has to be charged. The battery charger will start charging your battery, okay, as well as discharge also. Okay, now the power is coming to here. The power is coming to here. The DC power is coming to here. Now what is the inverter will do? It will convert DC to AC, DC to AC. Then again, after that ये continuous यहाँ पर है. After that, here yeah. So after that, what we have is, here we have a small triggering circuit. Small triggering circuit. I'll draw that triggering circuit. Then after that, we have filter. Filter आएगा. Then after that, the power comes to the load. The power comes to the load. Now filter में क्या, triggering circuit में क्या रहेगा? We have two SCR, okay, silicon control rectifier or diodes. We have two things like this. One is in forward bias, another is reverse bias. Then ये ट्रिगरिंग सर्क्यूट से ये ट्रिगरिंग सर्क्यूट को आ रहा है, इन्वर्टर के बाद में ये ट्रिगरिंग सर्क्यूट को आ रहा है. देन ये ट्रिगरिंग सर्क्यूट T1 है, T1. देन यहां से कहां जा रहा है? इट इज गोइंग टू द फिल्टर. Okay, you'll be getting some high pass filter or band pass filter or low pass filter or RNC filter. You'll be putting a filter, and from the filter the power is going to the load. This is the normal condition. Then we have one more circuit here. You'll have one more path here. This is another triggering circuit T2. Let us suppose it's a T2. Then it is going to filter and to the load. And to the load. Okay, now see here. When you see the triggering circuit here, यहाँ का जो triggering circuit है T1, it is NO. NO बोले तो normally open रहेगा. And here it is NC. T2 is nothing but NC, normally closed. तो यहाँ पर देखो, first when mains is on, जब mains on है, the first condition, case 1, when mains is on, जब mains power on है, the main power जाएगा. Okay, the main power will go like this. There are two paths, path 2 and path 1. So let us speak about the path 1. The path 1, the power is coming to your AC rectifier, which converts AC to DC. The battery charger is giving the power, and the battery charger will start charging the battery. The same supply will be coming to here, and then the supply will forms to the inverter which converts DC to AC. And what is the T1 condition here? Triggering circuit condition क्या है? NO. Okay, the triggering condition is NO. NO means it's open. It's an open condition. There is no chance of power flowing to the load from here. तो केस 1 में क्या हो रहा है? केस 1 में क्या हो रहा है? पाथ 1 के दौरान पावर जा रहा है और बैटरी चार्ज हो रहा है और यहां तक पावर रुक गया. Power has been stopped up here. So path 1, the power is going and the battery is getting charged and it has been stopped up to T1 circuit. The same supply which is going, the main input supply which is going to the T2 circuit, the T2 condition is NC, normally closed. Then normally closed यानी कि the power will go, and then as power is going, if I can't give this power directly to the load. क्यों? Because they are the diodes. Whenever you are supplying the power through a diode, electronic equipments, the waveform will get distorted. When the waveform will get distorted, you'll have a harmonic contents. आपका waveform में harmonic contents रहेगा ऐसा. So अब ये harmonic content अगर मैं लोड को दूंगा तो it will get damaged. तो उसी के लिए क्या कर रहे? End point before the load अपन क्या कर रहे? Filter लगा रहे. Filter लगा के इस filter क्या करेगा? Remove the harmonic content, and to get the purest waveform of AC, we employ the filter, and then we are giving it to the load. So when mains is on, path 1, the battery is getting charged, and through path 2, the supply is going to the load. Okay, this is when mains is on. Now when mains is off, जब mains power off है, तो ये power नहीं है ना अभी, mains power नहीं है ना? Yes or no? Yes. Okay, when mains is off, there is no supply now. There is no chance of power going to the low T2 now. Now whatever the battery which has been charged, that has to be discharged now. So whatever the battery which has been charged, that will start discharging to the inverter circuit, converting DC to AC. And जब इसमें छोटा सा relay coil रहेगा, you'll have a small relay coil which sends that power failure, and make this T1 from NO to NC. It will make the T1 from NO to NC. When it become NC, whatever the DC power which has come into the inverter which is converted to AC, that power will go to the filter and filter to the load. Okay, so there is no chance of power to the V2 now, only through this one only. So when main is off, the battery which has been charged will start discharging the power to the load. So in that we have a small relay coil in our home, in our UPS. That relay coil will sense the power failure and it will make the T1 from NO to NC. When it makes T1 from NO to NC, the path is closed. Then the supply battery which has been charged will start discharging the power to the load with the help of the circuit. This is called as an offline UPS. Why? Because in this UPS there is a problem. In this offline UPS there is a problem. What is the problem, guys, in this UPS? The problem is whenever there is a power cut happen, the relay will sense the power cut and make the T1 from NO to NC. okay, and make that even from NO to NC. During that there is a small interruption of power. That is the reason आपके घर में देखो इन्वर्टर रहेगा तो आप जब पावर कट है तो आपका जस्ट लाइट फ्लिकर होगा, your light will flicker. Okay, in our home we have a UPS. When you see, we call inverter. When you see, whenever the power goes, the light will flick. Whenever the power come back again, the light will flick again. Okay, the reason is because it have a relay coil which makes that NO to NC, and again when the power comes NC to NO. So it's a continuous process, that relay coil. That is why it is called offline UPS. Mean to say that there is some 3 to 5 millisecond power cut will happen when the power goes or when the power come back. This is called offline UPS. Now when it comes to online UPS, what is online UPS? 24/7. Okay, so 24/7. Now what happened is you should not have any breakdown in the power. Why? Because in the online UPS में क्या होगा बोले तो there are two paths here. ये एक path हो गया. Okay, now when you go with the online UPS, what happened is there are two paths. There's a path 1 and there is a path 2. First thing, then this will be always NC, this path will be always NC, and this will be NO. This will be NO. Okay, this will be NC and this will be NO. So now what happens, you see here, when the power is there, the first it will go through the path 1, rectifier which converts AC to DC. Battery is getting charged simultaneously. The battery power is going to the load. The battery power is going to the load through the inverter. Okay, then again converts AC to DC to AC. Then again we have a this one filter. Then again to the load we are giving. So when main power is on, the power is going through path 1. The power is going through path 1. Battery is getting charged simultaneously. The battery is getting discharged, and the power is going to the load. Now power is going to the load. Now when main power is off, so when mains is on, there is no chance of power going to this one because it is NO. So power through path 2 नहीं जाएगा. But जब main supply off होगा, will you have any interruption of power for a second? No. Why? Because 24/7 the batteries are connected to the load. 24/7 the batteries are connected to the load. Even the power is there, the power is going through this path also. Even the power is not there, the battery is also going through this path. So obviously the batteries are connected to the load on 24/7, so we don't need any coil to get activated. So this is called online UPS or double conversion UPS, where there is no short interruption of the power for a second. That is why it is called online UPS. Am I clear?
यस सर। और अगर वोल्टेज अगर 200 के नीचे रहा तो वो क्या आइडेंटिफाई करेगा, फिर पावर ऑफ कंडीशन लेगा क्या?
हाँ, लो वोल्टेज सेंस करेगा और वो रिले कॉइल जो है पावर ऑफ कंडीशन सेंस करेगा और मेन
हाँ,
पावर
तो
ऑफ
उसको
को
पावर
करेगा,
कट कर
पावर को
देगा।
ऑफ करेगा और मेन सप्लाई बैटरी चार्ज है वो डिस्चार्ज करेगा.
ओके सर।
Okay, right. So now in this consideration now, so these are called as a nominal voltage, high voltage and low voltage cutoff. That is nominal voltage is 230, high voltage cutoff is 253 and the low voltage cutoff is 207. Okay, now these are the standards. Now what is this battery cells? I'll tell you at the last. Now what is this one? Voltage required to charge the battery. What is this one? What is the selling is, if it's a 2-volt battery, अगर आपका 2-volt battery है, if it's a 2-volt battery, what is the minimum voltage required to charge the battery? So what it's telling, अगर मेरे पास एक 2 वोल्टेज का बैटरी है, वो 2 वोल्टेज का बैटरी को चार्ज करना है, तो what is the minimum voltage required to charge the battery? Like example, I'll tell you, when you are taking your mobile, when you are charging your mobile with your standard charger, mobile charger which is given by the branded company, it will charge very fast. But if the same mobile you are charging with a local charger, it will not charge within that time. Why? Because the output voltage of that battery charger is very much less, right? So the same way, what is this table is saying, that if it's a 2-volt battery, what is the standard voltage required? What is the minimum standard voltage required to charge the battery is 1.4. If it's a 12-volt battery, the voltage required to charge the battery is 10.5. 24-volt battery, what is the voltage required to charge the battery? 23.4. And 48-volt battery required 47.4 voltage is the 47.4 is the voltage required to charge the battery. Okay, these are the minimum voltage required to charge the battery as per the standards. Now we need to calculate the battery banks as well as the age of the battery. So now as per the client requirement, we need to take the data. So calculate the battery bank size calculation, for which we need a backup time for 2 hours. he need a backup time for 2 hours, and he want the type of battery is SMFB. So client is saying that he need a backup time for 2 hours. He need a backup time for 2 hours, and he want the type of battery is what? SMFB, shield maintenance free battery. As I told you, there are two types of battery. One is SMB battery, another is SMFB battery. SMB बैटरी मतलब है शील्ड मेंटेनेंस बैटरी है जो कि मेंटेनेंस करना है बोल तो कौन सा टाइप का बैटरी है ये? दे आर नथिंग बट लेड एसिड बैटरीज. दे आर नथिंग बट lead acid batteries where we need to pour the distilled water. Where we need to pour the distilled water, we need to do maintenance. Then there is another kind of battery called SMFB, shield maintenance free battery, which is also called as an what is it? Lead acid battery, and what is another battery? Lithium batteries. So this is a lithium batteries which works only on charging and discharging basis. Okay, we don't need to do any maintenance because it's a maintenance free battery. So there are two types of battery, SMB and SMFB, shield maintenance battery and shield maintenance free battery, or lead acid battery or lithium battery. So we need to know as per the client requirement whichever you want. So I need a backup time for 2 hours. I need a backup time for 2 hours, and here I've taken a type of battery, SMFB, shield maintenance free battery. I think I've taken SM. In the calculation, I think I've taken SMB. Let us take SMB. So I taken SMB battery, shield maintenance battery. Now let us do the calculation for this UPS, which we got 12 kVA UPS. Now, step 1. What is step 1? Calculate the number of cells. What is the formula for number of cells? Number of cells is equal to maximum allowable voltage by minimum voltage required to charge the battery. Number of cells का मतलब क्या है? What is number of cells? I'll tell you in the conclusion. But what is number of cells? Calculate the number of cells is equal to maximum allowable voltage by minimum voltage required to charge the battery. So what is the maximum allowable voltage? 230 plus or minus 10%, which I told you. That is maximum allowable voltage is nothing but 253. Okay, and minimum voltage required to charge the battery. I took 12 volt battery. For this 12 volt battery, what is the minimum voltage required to charge the battery? 10.5 is the voltage required to charge the battery. I taken 12 volt battery. For this 12 volt battery, what is the voltage required to charge the battery? 10.5 is the voltage required to charge the battery. So now maximum allowable voltage is 253. Minimum voltage required to charge the battery is 10.5. So what is the number of cells? 24.095 cells. What do you mean by this number of cells? I'll tell you. So the number of cells we got is 24.095. Now step 2. What is step 2? Calculate the end cell voltage. Now what is this end cell voltage? End cell voltage का मतलब क्या है? When you go with end cell voltage is nothing but minimum allowed voltage by number of battery cells. इसका मतलब क्या है? Let me tell you. Now example guys, when you take your mobile, when you are taking your mobile, you know in your mobile we have a low battery indication. Yes or no?
Yes, sir.
Okay, so what do you mean by the low battery indication? If your battery is getting drained and you got some 20%, then you'll get a pop-up saying that low battery indication. Mean to say that your battery is getting drained, okay, and if you still get drained, your mobile will get switch off, right? So that is called low voltage battery cutoff, where you'll get a beep sound and you'll get a pop-up stating that low battery cutoff. The same way in the UPS also we have a low battery cutoff voltage, that is called end cell voltage. Means ये 12 voltage का बैटरी को कितना तक अपन ड्रेन कर सकते हैं? You can drain up to 0 also, but you know the life of the battery is get reduced, okay, and we don't discharge the battery up to the dead zone, okay. So there is an end cell voltage. End cell voltage means in the UPS also you'll get a beep sound that your battery is getting less, okay, because continuously you are using the load and the power is not happening, power is not come, you'll get a low battery indication. Now when that low battery indication cutoff is called as that is end cell voltage. That is 207 is the minimum allowable voltage by number of battery cells. What is the formula? For end cell voltage is equal to minimum allowable voltage by number of battery cells. Now what is the minimum allowable voltage? The minimum allowable voltage is nothing but 207. Number of battery cells we got is 24.09. When I calculated, I got 8.59. इसका मतलब क्या है? एक 12 वोल्टेज का बैटरी को मैक्सिमम कहां तक अपन ड्रेन कर सकते हैं? 8.59 is a standard cutoff. But still, if you want to drain, you can drain and you can make it to 0. But this is a standard cutoff voltage for the low battery indication. That is 8.59 is the maximum cutoff voltage. That is end cell voltage. Now next one is calculate the DC current delivered to the UPS. Now what is that I need to do? अभी जो UPS है वो UPS को इनपुट सप्लाई दे रहे, तो वो UPS क्या करेगा? AC से DC को कन्वर्ट करेगा और बैटरी को चार्ज करना है. तो अभी मेरे को ये UPS कितना DC करंट डिलीवर कर रहा है, काय के लिए कैलकुलेट करना है? बिकॉज वो DC करंट को मुझे स्टोर करना है, and we need to discharge that energy for 2 hours for continuous load. I'm repeating once again. Here I'm calculating the DC current delivered by the UPS. Why I need to calculate the DC current delivered by the UPS? Because that UPS which you got it 12 kVA, UPS का साइज अपन पाया ना इधर 12 kVA, ये UPS मुझे ये लोड को पूरे को मतलब कितने सेस का UPS